How do engineers and scientists use mathematics? Engineers and scientists use mathematics to quantify, to explain, to model and to predict how physical, chemical and biological systems behave. Within such a system, there are often many variables. The position of an aircraft and its speed, the temperature and pressure in a chemical reaction vessel, the current in an electrical circuit, and so on. Variables are quantities that can change or vary and which are of interest to the engineer or scientist. Often one variable changes in response to changes in another variable. So, for example, if the temperature in a closed chemical reaction vessel is increased by heating the vessel, then the pressure within the vessel is likely to increase as a consequence. A chemist might be interested in how much the pressure changes as the temperature changes. We use symbols to represent these variables. Often the symbol is chosen from letters of the English alphabet. So, for example, we might use lowercase p to stand for pressure, uppercase T to stand for temperature, and lowercase t to stand for time. There are no hard and fast rules about which letters to use, though it should be clear that some choices are more sensible and more helpful than others. And of course, over the course of history, conventions have been developed. For example, it is almost universally accepted that the symbol for time is lowercase t. It is important to distinguish carefully between uppercase letters, like uppercase T and uppercase R, and lowercase letters, for example, lowercase t and lowercase r. In the mathematical description of a physical system, we might find both upper and lowercase letters used, as for example when we are interested in how the temperature T changes with time t. So you need to write carefully and be precise about which quantity you are referring to. A temperature might be measured on, say, 4 occasions. So what might be an appropriate choice of symbol now? In situations like this, we often use subscripts. Subscripts are small letters or numbers appearing to the right and slightly below the main letter. So, for example, we could refer to the 4 temperatures as T subscript 0, T subscript 1, T subscript 2 and T subscript 3, or for brevity just T0, T1, T2 and T3. The choice is somewhat arbitrary, but clearly some choices will be more sensible and meaningful than others. In an electrical circuit, the voltage at 2 locations, A and B, might be labelled V subscript A and V subscript B, or simply VA and VB. Similarly, we might use superscripts. These are small letters or numbers appearing to the right and slightly higher than the main letter, as in T superscript 0 and T superscript 1. Often letters from the Greek alphabet are used. Angles particularly are often labelled with Greek lowercase letters such as theta and alpha. For reference, the full Greek alphabet can be found later in this week's course material. Be aware that the use of superscripts can be confusing. This is because they are used in different ways and can mean different things depending upon both context and convention. For example, superscripts are also used to represent powers of numbers, as for example when we write 2 to the power 3 or 2 cubed, which means 2 times 2 times 2, or 8. It is very good practice to try to specify clearly the meaning of any notation introduced. there are many other mathematical symbols that you will meet as you study more mathematics. A summary of common ones will be provided later this week. It is often helpful to have a pictorial representation of relationships between variables, because this then enables us to visualize how changing one variable affects another. A graph is a special sort of diagram which is used to depict relationships between variables. Being able to draw graphs, to interpret graphs that others have drawn, and to understand the information that they are intending to convey are essential skills for the scientist and engineer. And these are the skills that we intend you to learn as you work through this course. We will see that pictorial representations often take the form of straight lines, and straight line relationships turn out to be very important in many applications. Sometimes the graphical representations take the form of curves, and it becomes important to find words to describe these curves. So to start thinking mathematically, we shall begin by simply inspecting a set of photographs, looking out for points and lines and curves, and thinking of ways to describe them.